going to expand the, let's see, the square root of 1 plus x with the binomial, that theorem. And that theorem says that 1 plus x to the k power is equal to the sum n equals 0 to infinity of k choose n times x to the n. If we expand that, the first term will be 1. The second term will be k over 1 factorial times x to the first. The next term will be k times k minus 1 over 2 factorial times x to the second plus k times k minus 1 times k minus 2 over 3 factorial times x to the third. Let me squeeze one more. Plus k times k minus 1 times k minus 2 times k minus 3 over 4 factorial times x to the fourth plus, well, following this pattern, I would have to say the nth term would be plus k times k minus 1 times k minus 2, etc., until you get to k minus, well, we're subtracting n minus 1 from k each time, where n is the power on the x, and also it's the factorial on the bottom. Okay, so that's the pattern that I'm seeing here. And that's x to the nth. And of course it goes on after that forever. Okay, so that implies that in our situation, we have the square root, which is the 1/2 power. We have 1 plus x to the 1/2 power. So k is 1/2. And that will equal, according to our expansion formula, 1 plus 1/2 over 1 factorial times x to the first plus 1/2 times 1/2 minus 1 is negative 1/2 over 2 factorial times x to the second plus 1/2 times negative 1/2. Okay, subtract 1 from that negative 1/2 and you'll get negative 3/2. All of that over 3 factorial times x to the third plus 1/2 times negative 1/2 times negative 1/3 times negative 3/2. Subtract 1 from that, you get negative 5/2, all over 4 factorial, and that's all multiplying x to the n, which is 4, plus dot dot dot. When you get down to the nth term, it looks like this: plus 1/2 times negative 1/2 times negative 1/3 times negative 3/2 times negative 5/2 times dot dot dot. Okay, now in each case, look at the fourth term, x to the fourth. N is equal to 4, and we stopped when we took 1/2 minus that index n in parentheses, minus 1, 1 less. Is that right? 1 less in the index. Okay, so let's see if that fits this 1/2 minus n minus 1. All of that over n factorial, and all of that times x to the n plus dot dot dot. So that's the pattern, and you can test it on x to the fourth power. We stop at negative 5/2 because that's 1/2 minus parenthesis 4 minus 1 in parentheses, which is 1/2 minus 3, which is 1/2 minus 6/2, which is negative 5/2. That's where we stop. And it's that pattern that established the nth term, where to stop the nth term. Okay, now let's actually simplify this, and we will get something that will start revealing a pattern to us. 1 plus, the next term ends up being x over 2. Now we get a negative term, and it is 1 times x to the second over 2 to the second in the denominator times that 2 factorial. That's the n equal 2 term. Plus, so we're alternating signs here, we have 1 times 3 times x to the third over the denominator. This time, if you look at the n equal 3 term, has a denominator 2 to the third times 3 factorial. And then we have a minus, and our denominator is 1 times 3, see, we're getting odd numbers here, times 5 times x to the fourth over 2 to the fourth times 4 factorial. So the power of 2 in the denominator, starting with the n equal 2 term, is just 2 to the n power times n factorial. And the numerator is doing something interesting. Let's look at this. This number 5, there we stop. We stop counting the odd numbers, 1, 3, 5. We stop at 2 times 4, which is equal to, minus 3. We stopped that 1 times 3 times 5 at 2 times 4 minus 3, and 4 is the index. Over here, where did we stop? Here we stopped at 2 times 3, that's 6. 2 times 3 minus 3 gives you 3. That's where we stopped that one. And this one, where did we stop this one? We stop at 2 times 1, which is 2. No, I'm sorry, 2 times 2, because the index is 2 here, minus 3. 2 times 2 minus 3 is 4 minus 3, which is 1. Well, if we follow that pattern, and we keep alternating signs as we go, eventually we're going to get to the nth term, and that will look like, let's expand this, 1 times 3 times 5, and it will continue. And remember, this is the nth term. So in the denominator, we're going to have 2 to the n times n factorial to fit the pattern, and at the end, we're going to have x to the n power. But where do we stop the 1 times 3 times 5? We're going to stop it at 2 times n minus 3, just as we did the others. And of course, there's plus dot 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 because it goes on after that. And it's alternating signs. So what we see is that there's a pattern established at n equal 2 term. But the first two terms, they do not fit the pattern. Do not fit the pattern, which just means we're going to leave them out in the front when we write this in summation notation. So our square root, our 1 plus x to the 1/2 power that we started with is equal to the first term plus the second term. They do not fit the pattern. And then we're going to start, let's see, we're going to add the rest of the terms, write it as summation. And remember, this pattern starts when n is equal to 2. So n equal 2 to infinity, it's an infinite sum. And to alternate the signs, we'll have a factor of -1. We want it to begin at negative when n is equal to 2, so we'll have it to the power n minus 1. And that will start as negative for that n equal 2 term. And then the pattern as far as the product of the odd numbers is 1 times 3 times 5, etc., until we get to parenthesis 2n minus 3. And the denominator, we have 2 to the n times n factorial. And this is all coefficients multiplying x to the n. So that is our binomial expansion. Oops. For the square root of 1 plus x with, because of the theorem says that it comes with the x, absolute value of x less than 1. Now, if it had been something other than x, if we had had like x over 3 or whatever we had in class, we would have solved that for the absolute value of x. That coincides with this situation, where the absolute value of x, because this is a Maclaurin series centered at 0, so it's absolute value of x minus 0, being less than r implies that the radius of convergence, r, is equal to 1.